This is another easy problem from Putnam in 1987. While the integral looks complicated, it is astonishing that the answer is so elegant. In fact, I can tell you now, the answer is the singleton 1. I will first let I equal to the integral to make the writing easier afterwards. Now comes the magic. The key is to use a relatively innocent u substitution, u equals 6 minus x. Let's take care of the lower and upper limits first. When x equals to 2, u equals to 4. When x equals to 4, u equals to 2. Also, since x equals to 6 minus u, dx equals to minus du. You can pause the video now if you want to try the problem before seeing the solution. Now we will do some housekeeping. 9 minus x equals to 9 minus 6 minus u, which equals to u plus 3. And x plus 3 equals to 6 minus u plus 3, which is 9 minus u. Also, to save some handwriting, I will define the function f of t equals to square root of the natural log of t. Now we can substitute u into the integral. The lower and upper limits are also changed accordingly. We are now integrating from 4 to 2. The numerator of the integrand is also changed now. Using the function notation and the u substitution, the numerator is now f of u plus 3. For the denominator, of course, we have f of u plus 3 plus f of 9 minus u. Since dx equals to negative du, I put the negative sign in front and put du at the end. Now we can get rid of the negative sign by swapping the lower limit and the upper limit. Everything else remains the same. Since u is just a dummy variable within the integration, we can replace it with any English alphabet. In fact, I'm going to replace it back to x. So now we have the integral of f of x plus 3 divided by f of x plus 3 plus f of 9 minus x. And this is our integral I. Now I'm going to add the integral I to this integral I. So we have I plus I equals to the integral from 2 to 4. In the denominator, using the functional notation, we have f of 9 minus x and f of x plus 3. So they are the same. I can put them together. As for the numerator, on the left-hand side of the I have f of 9 minus x. On the right-hand side, I have f of x plus 3. And we still have dx. Now everything is very simple. We have 2i equals to the integral from 2 to 4 dx, because the numerator equals to the denominator. And this integral, of course, equals to x evaluated between 2 and 4, and this is 2, so we have 2i equals 2 and I equals to 1.